Okay, questions on chapter 2. So this is when we got into like the inverse, converse, contrapositive, the inductive reasoning, deductive reasoning, knowing all your properties, that kind of stuff. So as far as properties go, you'd want to be able to like match them with a statement like you have like 17 through 19, almost like it would be multiple choice. Match it with the reason, and then also provide it in like a proof. Yep.
So the proof would be filled out, and then we have that.
One of them is part filled out, and then one of them is open-ended.
Okay, and there's only 2.
Correct. I think together they're 10 points, like it's 7 and 3 or something like that.
Are you gonna like, it's gonna be like on a shape or a line, or you're not gonna?
It's on shapes. Both of them are on shapes. Yeah. That wasn't me. Okay. Chapter 3. Questions when we get to chapter 3. Now we're talking about parallel lines, alternate interior, alternate exterior, all those relationships, linear pair, vertical angles on the bottom there, complements, that kind of stuff.
Are they gonna be true or false?
Yes. Yeah. More on some on the, like, could be like the intersection of two lines is a point, that kind of thing. And then also when you get to like the quadrilaterals, the stuff that we did at the end there. Yeah.
Can you do any one of the like 16 cases?
Sure. Okay, so 16 says write the equation of a line that passes through the given point and has the given slope. So you have two options when you're plugging in, and that is y equals mx plus b, or y minus y1 equals m times x minus x1. So if you were choosing, Zoe, which one would you choose? Well, that was weird, Zoe. You had your voice come out of neck. This one? Okay, so if you're picking, let's say we do 16, right? If we're plugging into there, the first round, I plug in the x, the y, and the b. The x, the y, and the m. Solve for b, and then I got to plug back in the m and the b. So the first time, my x would be the -2, my y would be the 4. So it would be 4 equals, the m is 3, times x, which is -2, plus b. 4 equals -6 plus b, add the 6, and b is 10. But then you have to plug back in the m and the b. So y equals your m, which was 3, x plus b, which is 10. And there's the equation. For something like 19, let's say, because that one's a little bit different, 19 says passes through the point, but is perpendicular to y equals 2x minus 1. This time you have to find the slope of a line that would be perpendicular to this one. So the slope of that line is what? What's the slope of the original line, though? 2, right? Because this is already in y equals mx plus b form. If it wasn't, you could solve for it and get it into that form. So what's the slope of a line that's perpendicular to it? -1/2. Switch this sign and flip it. So now I'm using these two pieces of information. So if I did this is my x, this is my y, this is my m, it would be 3 equals m, which is -1/2, times x plus b. 3 equals -1/2 plus b, and then add the 1/2. So b is either 3.5, or you could write it as 7/2. And then you have to plug back in the m and the b. So y equals -1/2 x plus 7/2. If it had given you like the slope of a line parallel, then you don't change it, right? So parallel you don't change. Obviously, if they give you the slope, you don't change it. But if it's perpendicular, you flip it and you change the sign. Any other questions on chapter 3? 4 was only remember we did that one section of notes in 4 where we blended together 1, 2, and 3. We did the translations and all that stuff. That's not on your midterm, which is why it's not in this packet. Nope. So 5 was now we went into triangles, right? So classifying triangles, using the angles inside the triangles, and we ended with our proving triangles congruent, or the CPCT stuff where you prove stuff about the triangles if they are congruent. Yeah.
Yeah, CPT, like this, if you want to find like a certain side length or a certain angle.
Right. And you can prove the triangles are congruent, then the next step would be CPCTC. So like if it said quick proof. If instead of 12 ending there, it went to, what's it say? ABC's isosceles. Let's say I wanted to get that angle ABD equaled angle CBD. Like that's where I wanted to go. I could start with the same information, so I'd still start ABC is isosceles with base AC, and then BD bisects, oops, let me give you a different angle now, because that's the same angle. So this, let's say, angle BDA equals angle BDC. So this is all given to you, and on your diagram, there's nothing marked already, okay, because technically you have to know what it means to be isosceles and you have to know what it means to bisect in order to get that things are actually congruent. So because it's isosceles and it tells you the base is AC, it tells you that so that you would know AB and BC are the legs. So AB would equal BC, and that's the definition of an isosceles triangle. Then it gives you that BD bisects angle B. So what does a bisector do? Cuts it into half or into two congruent parts, right? So I could say that angle ABD is equal to angle CBD because that's a bisector, so it bisects it. And then what piece of information can I pull from the, definition of angle bisector. What piece of information can I get from the diagram itself? Good, the reflexive side is there. AD, or BD. BD would equal BD, and that's reflexive. So now is there enough information to prove the triangles are congruent? Yes. And what's your reason? Good. So triangle ABD would be congruent to triangle CBD, 5 side angle side. So that's where the example that was already there ended. But if we wanted to go one step further and then say that angle BDA equaled angle BDC, good, CPCTC. And if you forget, congruent triangles have congruent parts. Like, that's basically what it is, okay? On one of the tests, I even took, like, a definition of congruent triangles, because it's basically the same thing. So I would say, I would put money that at least one of your proofs is going to come from the triangle error. Questions on 5? Okay, then 6 was all those special segments, angle bisectors, perpendicular bisectors, altitudes, medians, and what did I miss? Altitudes, medians, angle bisector, perpendicular bisectors. And then later came the mid-segments. So there was a lot of theorems. Really the ones you need to know the most of are like it's equidistant from the point where the perpendicular bisectors meet to the vertices. It's equidistant from where the angle bisectors meet to the sides. And then the 2/3 theorem were the 3 theorems because the other ones are just the converse to it. And then knowing how to find the coordinate points, which we went over on the notes, but knowing how to find the coordinate points of the circumcenter, the orthocenter, and the centroid. You have to know how to find those, which is either at the midpoint of the right angle, at the midpoint of the hypotenuse, at the right angle itself, or add the 3 and divide by. Add the 3x's, divide by 3, and add the 3y's, divide by 3. Questions on 6? Sure. So 8 says in the diagram, at the right, the angle bisectors of triangle XYZ meet at point D, find DB. So we're looking for this little, let me do a different color, this little segment here. Because it's the angle bisectors, I know that they are equidistant from the sides. So all the blue segments in this picture, which your test is going to be black and white, so it's obviously not going to be color-coded, but all of those blue segments would be congruent. So I just have to find one. Because in this triangle, I have this side and this side, I can use the they wouldn't be this big, but I can use the Pythagorean theorem to find this missing side, which is 7. So a squared plus b squared would equal c squared there. And then you'd get that missing side is 7, which means any of these are 7. You need to know about the angle bisectors being equidistant from the sides, not so much about the Pythagorean theorem. Yeah.
Can you zoom out really quick?
Sure. Like how far?
So like the whole page.
Yeah.
Thank you.
You're welcome.
Are the postulates and like the theorems for this and are they used on the test pictures and then on the other test?
You like the names of them or knowing what they say?
Like what they say, I guess.
Like the fact that they're equidistant from the sides. Yeah, so you have to differentiate, right? Because the angle bisectors meet at a point that's equidistant from the sides, whereas perpendiculars meet at a point that's equidistant from the angles, and then the 2/3 one is like the centroid, which is like 9, 10, and 11. Those, you have to know that 2/3 one. So it won't ask you for the name of them, but you do have to apply it. Yeah. Sure. So 14 says if JKM, which is this angle here, is greater than LJK, which is this angle here. So let's just say this is 50 and this is 40. We have absolutely no idea what the actual measurements are, but at least I get an eyeball on which one's bigger. It says which one's longer, LK or MJ. In the directions, it says JL is congruent to MK, so you have one pair of congruent sides. And then they share that reflexive side, which means you have side angle side here, or the hinge theorem, which says that if the two sides are congruent and the angle between one of them is bigger than the angle between the other, then the side opposite the bigger one, so JM, is going to be bigger than the side opposite the smaller one, which would be JK. So MJ or JM is the bigger one because it's opposite the bigger angle. Other questions from this one? Yeah. 17 says, describe the range of possibilities from the... Okay, so you have two side lengths, right? You got to know what the third side length is. Remember, the range is it has to be bigger than, so it's got to be greater than the difference of those two sides, but less than the sum. So the difference between 9 and 7 is 2, and the sum is 16. So it has to fall somewhere in between them. Less word problem-y and more diagram-based, I would say. Yeah.
Are there going to be any word problems on our test?
Not really. Are there words like supplements and stuff like that? Yes, but like not like that. All right. 7. Now we got into our polygons. So interior angles, exterior angles, and then your quadrilateral parallelograms. Then we went more specific to rectangles, rhombuses, and squares. And then outside of that parallelogram group was your trapezoid and your kite. They're still quadrilaterals, but they're not parallelograms. Questions on those? So again, if you couldn't fill in that diagram of like the Venn diagram of all those properties, like if you can't do that by memory, I would say that's where I would spend a little bit of tonight, because you definitely want to know which one applies to which. That's where true or false are going to get you. And that's where questions where you have to like apply those properties are going to get you. Yep. When I was going to say when the pass comes back, but she's at the door.
Do we have to show up for like all the classes? You can just show up.
So if you're exempt A, you just have to come to C.
Okay.
Yep. And if you're exempt, yeah. If you have A but you're exempt C, they can leave. Yeah. Just watch your time. Because if you come right before the class starts, people are going to be coming right before the class starts. So there's a little bit of a break, and if you come early, you can come here. Like I'll be in here, you can come hang. Okay. And if you're done with A and you want to get some fresh air and then come in, that's fine too. I think they have the student center open for snacks. I think so. If they're smart, they do. Everybody's good on the packet itself, yes? Okay. So 17 says in trapezoid W, X, Y, Z, W, X, and Y, Z are parallel. So when I draw out the parallelogram, if I do W, X, Y, Z, I want to make sure that the parallel sides match what they gave me. WX is parallel to YZ, so it makes sense to draw it that way. If you started W like on the right, like if I did WXYZ, my diagram would not reflect the parallel sides being the ones that are matched. So like that's what you want to check. Kumar just left when he comes back. So then it says YZ is 4.25 centimeters, and the mid segment of the trapezoid is 2.75. Find WX. So I can use my formula, base 1 plus base 2 divided by 2 equals the mid segment.
You just solve it.
And I could just solve for base 1, right? Or I think easier is find the difference between these two. So 4.25 minus 2.75, which is 1.5. And then because I'm missing the smaller side, I would subtract it from the 2.75. And that's where you get the third side. So if it was the bigger side I was missing, I would add to it. If it's the mid segment you're missing, you're going to add them and divide by 2. So just, I would say be really careful what you label. That one, like if you get the wrong leg, obviously it's going to be different. And then the one that's like the midpoint question where you got 2 coordinate points, people make mistakes on that one by not reading it really careful. If it gives you the 2 end points, then you add them, divide by 2 to get the midpoint. But if it gives you an end point and a midpoint, you have to set it up and solve it. So just be really careful and make sure you read thoroughly. Timing-wise, you should be fine if you know what you're doing, and you should have time to go back through this test because so many of them are like not vocab-based, but quick. They're not like long concepts. The timing on it should be fine. You'll have almost the entire time. Like we'll come in, you'll take attendance and that kind of stuff, and then I'll get you started. You just want to, and I'll put the timer up, and I'll constantly remind you like halfway, that kind of stuff.
How many questions is it?
50, well, it's 47 with the proof. Yeah. 35 are multiple choice.